Well, hello there. We're going to have a look at adding and subtracting some algebraic fractions today. This is a fundamentally important area in mastering the language of maths. So let's have a really good look at this, and I hope I make it easier for you from now on, okay? Alright, here's two to start off with. Now, this one here, this has different denominators. Now the rule in maths is you cannot add fractions or subtract fractions if the denominators are different. Same thing over here. This is a problem, okay? So we have to deal with that, okay? So let's go with A. As I say, you can only add fractions if the denominators are the same. So we have to make them the same in order to be able to add them, okay? So let's see what we can do there. Now, we've got to find what's called the lowest common multiple of 3 and 2, which means that the lowest number that both of them will divide evenly into. Now that's an easy one to work out with 3 and 2 because they're both prime numbers, and therefore we know that 3 times 2 is 6, and that's going to be the lowest common multiple of 3 and 2. So that's the number we're going to use, okay, for the denominator. Right, so what we've got that. Now, you have to make both of those denominators into 6. So what do you do to this one? To make this 3, to make it into a 6, you have to multiply it by 2. And therefore, you have to do the same to the top, otherwise you change the proportion of the top compared to the bottom of this fraction, which is no good. You've got to keep the relative proportions the same. So you do that. Now similarly over here, you've got to get this 2 into a 6. So you've got to multiply that by 3, and you do the same to top and bottom. Now we simplify that. Yes, that doesn't alter the proportion in either fraction. So when you then fix that up a bit and simplify it, you get 4x over 6 minus 3x over 6. Now we can add and subtract them because the denominators are the same. Okay, so put it over one great big gigantic fraction just over 6, and we've got 4x minus 3x all over 6. And as you know, 4x take away 3x gets you x. So the answer is x over 6. Yes? Terrific. Now let's do B. Well, now this is a little bit more complicated because you might be able to see that the lowest common multiple of 6 and 4 is not 24. 6 fours are 24. It's actually 12. But I'm going to show you the systematic mathematical procedure required to work that out if you couldn't see it, right? This is like the training wheels way, the systematic go from scratch method, right? So we've got this, haven't we? Now we need to make the denominators the same. Okay, so we've got 6 now. What you do, doing it systematically, you split this up into its factor tree components, its prime number components. So that's 2 times 3. You do the same thing to the 4. 4 is 2 by 2. Now, this is the LCM, lowest common multiple procedure, guys. We always use all the factors of the first denominator, which is 6, when finding our lowest common multiple for our denominator, and then we use only those from the second number, the second denominator, which is the 4, that are not already selected from the first one. Now I'll show you, that sounds like double Dutch, I'll show you. So you've got 6 equals 3 times 2, now and you've got 4 equals 2 times 2. Now for your lowest common multiple, you take all of those factors from the first denominator, which is the 6. So you put them down as part of your lowest common multiple. Now you go over to the 4 and you say, right, guys, only those which are not already represented down here are allowed to go. Not the whole thing, just what already isn't there. I'll show you as we go. So you say to yourself, well, is there already a 2 down there? Well, there is. So you don't put that 2 down there, right? Then you say, well, is there a second 2 down here in our LCM, because this is a second 2, right? And there isn't a second 2, there's only a first, if you like, a single 2. So you put the second 2 down because that's not already represented in the LCM. See? All of the first term and just the leftovers, if you like, or the ones that already aren't represented from the second term. So our LCM, guys, is going to be 3 times 2 times 2, which is 12. Okay? That's how you do it. That is the systematic mathematical procedure required to find the lowest common multiple. And this can come in very handy when you're doing algebraic ones, which get a little bit more nasty looking. Okay? So now we're just going to do, we've worked out the LCM, we're just going to do the maths now. That's the first term up here, x plus 1 over 6, and we're going to multiply it. Now what do you need to do to 6 to make it into a 12? You need to times it by 2. So you do the same top and bottom. There you go. Now the second term was this one from up here, and we're going to multiply that 4 by what to get to 12? 3. And we do the same top and bottom. Yep. Excellent. Now, we'll go over the page and recap. That's where we got to. Now we're just going to simplify this now. So that's what we've got. Remember, this x plus 1 is a single term in brackets. It's a little family unit, a little algebraic family unit. The whole thing needs to be multiplied by that 2. And on the bottom, we've just got 6 times 2, which is 12. Over here, you've got the whole of this little family unit, x plus 4, multiplied by 3, and on the bottom you've got 4 times 3. Now, what we're allowed to do now is basically just simplify that and put it over the same denominator. So therefore, it's 2x plus 2, remember the whole of this x plus 1 is multiplied by 2, plus 3x plus 12, the whole of this x plus 4 terms multiplied by the 3, over 12. Now we can collect our mother duck can collect her ducklings. We've got how many x's? 5, and we've got a 2 plus a 12, which gets you 14. There's your answer, guys. Okay, that's how you do them. That's how you do them. Yes? Great. Yes, smiley face for us. Now, here's the next one. It looks pretty ghastly, doesn't it? Because we've got all these funny-looking beasties on the denominator, these x's. However, there's good news, because the procedure that we use to find the lowest common multiple of 3x and 4x is exactly the same as what we just did in the previous example in principle, except we've got some pronumerals to grapple with, but the principle is the same. So before we can add or subtract the fractions, we must make the denominators the same. So let's look at our first denominator. Our first denominator was 3 times x, and our second denominator was, now 4x is, now that's not exactly broken up into its finest prime number components. It would be 2 times 2 times x. Alright? Now let's go to our LCM. We take all of the first term there and that one, right? Now from the second term we say, alright, we haven't got a 2, so we'll put that down, and we haven't got a second 2, so we can put that one down, but we do have an x. There's an x already there, so we don't put that x down. It's already there, represented in the LCM, right? So that's the end of the line, and our LCM is 3 times x times 2 times 2, which is 3 times 4, which is 12 times x. There you go. Now once you've got that, look, it's just, you're laughing, because all you've got to do now is just make the denominators the same. You've got to make them both into 12x, and we know how to do that. You see, that's what we had, right? So now we're going to make the first term into 12x by multiplying the top and bottom by 4, and we're going to make the second term into a 12x on the denominator by multiplying top and bottom by 3. Okay? Simplify, we've got 8 over 12x minus 3 over 12x. Now we can add and subtract the fractions, and we can just put it all over the one great big fraction, which is 8 minus 3 over 12x. And what's 8 minus 3? Yes, 5 to keep us alive and help us to thrive over 12x. Yeah? Excellento. So you've got that one now. Okay, there's 2 more to do. They're getting more algebraic now, so fasten your seatbelts. This is the next one. Gracious me. Well, I think we'll put some brackets around those bottom terms there before we do anything else. Now, same rules, same rule. This is a family unit, standalone family unit. It's x plus 3. This is another one, x plus 2. Just for example, if x was, say, 1, that'd be 4, and that'd be 3. That's all it means. It's just a single number, which is made up of x and 3 added to it. In this case, it's a single number x with 2 added to it. So they're a single term. That's what I'm saying to you. A single family unit algebraic term. So, yes, before we add up and subtract the fractions, we must make the denominators the same. So let's go for it. Here's the first denominator, and here is the second denominator. Okay, so with your LCM, basically you say, well, I'll put all of that term down, and of course over here I'm going to put all of that term down because it's different from the other term that's already down there. So there's our LCM, guys. There is our LCM. So let's go for it now and make the denominators the same. So what are you going to do to this term to make this denominator, to make it that? You're going to multiply it by that, top and bottom, aren't you? Very good. Now what about the second term here? We've got to make that into that. So we're going to multiply it by x plus 3 over x plus 3. Excellento. Now, let's just basically just put that over one big fraction. Yes, we can add and subtract them, thank you. And we'll put it all over the one big fraction now. Now look, guys, see this, if I multiply that out, I'll get something x squared plus something x plus some number. It's a quadratic, it's called. This one here is also going to give us something x squared plus something x plus some number, right? Now that means that the mother duckling is going to come into play and collect all her mother duck's going to collect all ducklings, and you're going to have two x squared terms, two lots of x terms, and two number terms, which you can then just basically simplify. So we would want to multiply this line out and simplify it, right? However, the bottom, look, it really doesn't matter because there's just going to be one x squared term, one x term, and one number term, so there's really no point, one consolidated x term that is, and one number term. There's really no point multiplying those brackets out. We might as well just leave them like that, okay? But there is a point in multiplying these ones out because you're going to have two lots of x squareds, two lots of x's, and two lots of numbers once you simplify each particular term, this one and this one, which you can then consolidate and simplify. Hope you understand all that. Well, let's just do it to make sure we do get it. We'll multiply the brackets out on the numerator and collect like terms. Now, see the green arrow? What's that going to get you? Yes, that's right, x times x. This one's going to get you 2 times x, or x times 2. This one's going to get you 1 times x. This one's going to get you 1 times 2. Now, next term over here now, we're going to get, okay, 2x times x. This one's going to get us plus 2x times 3. This next one's going to get us minus 1 times x, and this one here is going to get us minus 1 times 3. Right, it's all over that thing. Now let's just simplify this big mess up here, see what we can get. That's x squared plus 2x plus x plus 2 plus 2x squared plus 6x minus x minus 3, all over that. Now we're just going to get Mother Duck into play here to collect her ducklings. So we've got 3x squareds, can you see them? There's 1x squared there, and there's 2x squareds there, right? Now what about the x terms? Let's see. 2x, 3x, 9x, 8x, yeah? Good. What about the numbers? Now we've got 2 here and minus 3. I get minus 1. Yes, excellent. And that's the answer. That is the answer, guys. Well, see, that wasn't so bad, was it? Once we basically applied our rules with the denominator business, we got it out, didn't we? Okay, we better get on to the next one now before we spend too much time on all this stuff. Now, this one here is a beastly looking thing, but exactly the same rules apply. So, put a bracket around that little guy there, and let's go for it. Yes, we have to make the denominators the same. So the first denominator has got an x minus 3, And the second denominator has actually got an x minus 3 squared, or x minus 3 times x minus 3. So for our LCM, what do? We basically say, yes, we'll have u, because we'll have everything from the first denominator. And we only have what isn't already represented down there in the LCM line from the second denominator. So we do have an x minus 3, so we're not going to put that one down, that first x minus 3. But we haven't got a second one. So we put that second one down. Okay, so it looks like our LCM is basically x minus 3 times x minus 3. Okay, well, let's do the denominator manipulation bit now. Okay, we've got that there. We're going to multiply that top and bottom by, well, we have to make it into this beastie, don't we? So we're going to multiply top and bottom by x minus 3. Now the second term basically is already got the x minus 3 times x minus 3 on the bottom, so we don't need to do anything to it to basically fix it up anymore. Now we can add up the fractions because they have the same denominator. So let's put them over the whole great big gigantic one single fraction, and there they are. Now, similarly as in the last example, I can multiply this out because there'll be some x squared, there'll be an x squared term, there'll be some two x terms, and there'll be a number term, and we can then combine that with here basically to simplify it a bit, yeah? There's no point multiplying this out because you really can't simplify that any further. Okay, so let's go. We've got, what do we got? X times x. Here we've got minus 3 times x. Here we've got 2 times x. And here we've got minus 6, or minus 2 times 3. And then we're just saying plus x minus 1 without the bracket there for that second term over here. Right, and it's over that denominator. Now we're just going to fix all this top line up. Looks like x squared minus 3x plus 2x minus 6 plus x minus 1. Now let's get Mother Duck on the job. Oh, look at that. That's very nice. Minus 3x, and there's 2x and another x there, which is plus 3x. So all the x's have gone. Terrific. So that's going to be x squared minus 6 minus 1 is minus 7 over that, and that is our answer. Okay, how do you feel? Yes, well, I feel pretty good too. So this is the little summary page here for algebraic fractions. What have we got there? Algebraic fractions contain pronumerals and may represent particular numbers, which may represent particular numbers or changing values. That's the pronumerals. To add or subtract fractions, we perform the following steps. We find the lowest common denominator by finding the lowest common multiple of the denominators. We rewrite each fraction as an equivalent fraction with the same denominator. We express it as a simple fraction, and we simplify the numerator, just like we've been doing, okay? Right. Go get them, guys. Go get them. They're waiting for you to conquer them and be victorious over them, and your algebra skills will get much better in the process. Okay, thanks a lot, thanks for listening, and do some practice, and we'll see you next time. Bye.